Okay, so in this final problem set, which is about decision analysis, I copy and pasted the problem set from the Word file into a PowerPoint so I can draw things, and because I want to show more than what's actually being asked. So assume Sam considers a new investment which can generate a profit or loss with subjective probabilities: profit 0.6, loss 0.4. If Sam does not make the investment, his income will be 10. If the investment is undertaken, his income will be 20 if it generates a profit, but negative 10 if it generates a loss. Sam can consult an investment expert who can evaluate Sam's investment plans as likely success or failure. So Sam subjectively believes that if the consultant tends to see a profit, it will give a verdict of likely success with probability of success given that they see a profit. So those are the subjective probabilities. So let's do that again in green. So first thing that we need to remember is that the probability of success given profit is equal to 0.8. Well, that implies that because the investment consultant will only say likely success or likely failure. So that means the probability, what does the consultant say again? Success or failure, so the probability of failure given that the consultant sees a profit, that then has to be 0.2. Then the probability, so Sam believes that the probability that the investment consultant will conclude a success if they see maybe most likely a loss, that is very low. Actually not that low, it's 0.4, so it seems that Sam is very optimistic, but that means that the probability of failure given that they see a loss is something that Sam believes to be 0.6. And again, those are subjective probabilities. So when we talked about probability, we said there is the a priori approach, like rolling a die. We know the a priori probabilities, the empirical approach. Well, this is the subjective approach. So this is basically given, and yeah, we need that later. Okay, so next I want to draw the decision tree that Sam faces. So Sam thinks that he has a new investment opportunity. So what he can do is he can decide, shall I invest? So that's a decision tree. Or shall I not invest? And what's given is, if Sam invests, there is a chance that he makes a profit but it could also be that he makes a loss. And initially, Sam thinks that the probability of making a profit is 0.6, and the profit of making a loss is then 0.4. And if he's successful, he makes, if the investment is successful, makes a profit of 20, but if not, loses 10. And if he does stay, if he does not invest, he can earn 10. Okay, so this is Sam's decision tree. And let's first start with whether Sam would make the decision. So let's first calculate the expected value of the investment. So the expected value of investing is, with the probability of 0.6, makes 20. So that's 12 plus, with a probability of 0.4, makes a loss of 10. So that would be equal to 12 minus 4, so that's 8. So because the expected value of investing is less than what he gets if he does not invest, the decision is not to invest. So the conclusion is not invest. That's the decision. Okay, but now let's introduce information. And what would happen if Sam had access to perfect information? So the next question would be, what is the expected value of perfect information? Okay, so the expected value of perfect information would be, okay, so there is a source that Sam can tap that has perfect information, and then Sam would approach that source with an initial probability of 0.6 that he makes a profit, and then if the perfect information source says that, yeah, you make a profit, then Sam will invest and makes 20. But Sam also approaches the source of perfect information with a probability of 0.4 that he makes a loss. And if the source of perfect information tells Sam, yeah, you make a loss, well then Sam would go and not invest and gets 10. So now the expected value of perfect information is 12 plus 4, which is 16. And the willingness to pay for the perfect information would be 6. Okay, so again, the willingness to pay is the expected value of perfect information minus what you have for sure. Okay, so there is no perfect information, but this would be the expected value of perfect information. Okay, so now Sam has the opportunity to consult an investment expert, and that opens up a completely new decision tree. So, okay, so now I gotta maybe draw it here, and maybe so we have more space. Okay, I hope that's enough space. Okay, so the first decision is, shall I consult, yes or no? So consult or not consult. Okay, and we have just seen if Sam doesn't consult, he will just stick with his probabilities. He will realize that the expected value of investment is less than what I have for sure and will not invest, and then gets the 10. Okay. So, but if Sam consults, there is a chance that the consulting company comes back to him and tells him, we think this will fail. So one verdict could be failure. And of course, what Sam would like to know is, what's the probability of failure? Okay. And if the verdict is failure, then a decision needs to be made of, shall I invest or not? So now here's a decision node, and now again the decision has to be, shall I invest or shall I not invest? And again, if Sam does not invest, he gets the 10. But if he decides to invest, then Mother Nature can reveal that he either makes a loss or he makes a profit. Okay. So that can happen. Can either make a profit or a loss. But now the probability of making a loss depends on what the consulting firm tells him, or the expert. So now what that is here, that's the probability that Sam makes a profit, given that before the investment expert says, I don't think this will work, this will become a failure. Okay, so we need to know that probability, and likewise we now need to know the probability that Sam makes a loss, given that the investment company is not too impressed. Well, initially Sam believed he makes a profit of 0.6. Well, if the expert tells him that this is probably a failure, this will probably reduce his profit expectation. Okay, so then, but nevertheless, if the profit is successful. If he makes a profit, he makes 20. But if he makes a loss, he loses 10. Okay, so this is what happens in the case of failure, but the consultant, if Sam is lucky, comes back and tells him that there's a chance, or that it looks promising, it looks successful, likely. Okay. Then we need to determine what's the probability of success. Okay. And then again, Sam needs to decide, even if I get like a good evaluation by the expert, now I need to decide again, shall I invest? And I need to prorate the space. Okay, invest. Okay, and when I invest, I can make again a profit. If I'm lucky, I make a profit. But if I'm not lucky, I make a loss. And of course, we want to know what's the probability now that if you get a good result, that the investment expert likes the project, then what's the probability now that we make a profit given that the expert likes it? So that's the probability of profit given that the expert says this is likely successful. Okay, and likewise, what's the profit? What's the probability that we make a loss given that the expert says this looks successful? Well, this is obviously good news, and the probability of profit and success, given success, probably increases the initial probability of 0.6. Okay, but we still need to complete the decision tree, which is not invest. And then we get again here the 10. And here we get 20 and negative 10. Okay, so now let's begin with what Sam really wants to know. So he really wants to know, if I get the evaluation from the investment expert that says, oh, it looks like a success, how much is my new profit now? But in order to answer that, we need to insert those subjective probabilities. But let's just figure out what that is. And this requires space theory. So by base theory, okay, let me see if I can squeeze that in maybe here. So, okay, maybe, okay. So the question is, what's the probability of profit given success? And this is equal to the probability of profit times the probability of success given profit. Okay, so let's just do this for now. No, let's just be complete. Okay, and now we have to divide over the profit, over the probability of success. Okay, so what do we already know? So what happened is that Sam approaches the investment problem with a probability of 0.6. That he makes a profit. And he thinks that the probability that he gets back a successful evaluation, given that that investment banker somehow looks at his investment plan and likes it and sees it at a profit, that was 0.8. Okay, so that means there is already a 0.48 chance that, you know, he can expect a success verdict. But we also still can get a there's also a success verdict can also increase the probability of a loss. So we also need to calculate what's the probability that we make a loss given success. And by Bayes' theorem, that's the probability of loss times the probability of success given loss over the probability of success. Okay, so that is 0.4. So because the investment expert is approached with a probability of 0.4, and you know, same things that, you know, even if the expert sees in the investment plan a loss, there is still a 0.4 probability that the expert will come back with a statement that says it looks successful with a probability of 0.4. Okay, so now what's the probability that Sam can expect success? Well, they can expect 48% success probability with his 0.6 approach of 0.6 and a 0.8 return by the investment expert who sees a success given if the expert likes a profit. So that's 0.6 times 0.8, that's 0.48. But he also thinks that there is still a 0.4 probability that the expert says loss. Even if the expert thinks there is a loss, there's still a 0.4 probability that the expert will conclude it looks successful, and that needs to be multiplied with that initial probability of 0.4. So the total, the probability of success can be written as the probability. The formal way of writing it would be the sum of the probability I, where I is either profit or loss, times the probability of success given what the expert can see, which is I call that recommendation. The recommendation could be, and I'm sorry, what the outcome is, just given, event I, profit or loss. So that means we do 0.6 times 0.8. So that would be 0.6 times 0.8. So that is 0.48 plus 0.4 times 0.4, that's 0.16, which is 0.64. Okay, so the probability of success that Sam expects is 0.64. Okay, so in other words, so that's a probability, and then of course the probability of failure should be 0.36, but we have to calculate that separately. Okay, so now what we still need to do is, so now we can calculate the entire probability profit given success, and we said this is 0.48 over 0.64, and here we have the probability 0.16 over 0.64. Okay, so this one, 0.16 over 64, that is 1/4, and this is 3/4. Okay, so now we calculated this as a 0.75, 3/4, and here this is 0.25. Okay, so now we have to do the same thing for the lower branches of the decision tree, so I can erase this here. Okay, so what we want to find out is the probability of profit given the fact that the investment person thinks this looks like a failure, and that's the probability of profit times the probability of failure given profit divided by the probability of failure. And we already know we should get 0.36, but I want to make sure that you see that the math makes sense. So probability of failure. Then we have the probability of loss given failure, this one at the bottom. That's the probability of loss times the probability of failure given loss. Over the probability of failure. Okay, so now we can plug in again the numbers. Okay, probability of profit 0.6 So in other words, Sam approaches the investment expert with a probability of 0.6 that he makes a profit, and he believes that somehow if the expert sees a profit, the probability that he will come back with a failure, the probability of failure given profit, that is only 0.2. So times 0.2. So that is 12%. Okay, and for the loss, so that Sam also approaches the expert with a probability of 0.4 that he makes a loss, but there is still a 0.6% chance, which is the failure given loss of 0.6. Okay. So in other words, so Sam approaches the expert with a probability of 0.6 that he makes a profit, but the probability of returning, with the failure is only 0.2, so that is a total of 0.12, and here we have so that's 12%, and here we have 24%. So in total, Sam expects to receive a failure with a probability of 0.12 over a plus 0.24, so that's indeed 0.36. So again, what we do is we sum up the probability of profit or loss times the conditional probability, in this case failure, given whether it's a profit or a loss. And again, these here are always the subjective probability that come from here, so the second term. Okay, so now we have here 0.36. So what we still need to do is divide everything by 0.36. 0.36. So here we have 12 over 0.36. So that is roughly 1/3, or let's just say 0.33. And the probability of loss given failure is then roughly 0.67. Okay, so this is really the important decision tree. And by the way, so now we could already answer this question. What will be Sam's subjective probability of profit if the consultant arrives at a verdict of likely success? P, profit given success. So that is the 0.75. But let's just keep on going. So, okay, so now we have determined the total probabilities of success. And so let's create again some space. Okay, so almost done. Okay, so now so now we have all those updated information. So what will Sam do? What is the best decision under this imperfect information? So So in decision analysis, we like to say that a good decision maker looks forward but plans or reasons backwards. Okay, what happens if we get success? Shall we invest or not invest? So now we calculate what is the expected value or payoff of invest given that the expert says, I think this looks like a success. Okay, so this is 0.75 or 3/4 times 20, and with a probability of 1/4, -10. Okay, so this would be equal to 15. So 60/4 is 15, but then minus 2.5. So that is 12.5. Okay, so the expected value of investment is 12.5. So let's write that here. And that is obviously greater than the 10. So we would invest. So the decision is now that we would invest. And we will eliminate not to invest. So in other words, if the investment expert tells us, oh, it looks successful, then we decide and invest. So the decision is invest. Okay, but what if we get told that it looks like a failure? Okay, so then what's the expected value of investing if it's a failure? I mean, if the expert says it is a failure, so then we have to calculate this one. And so now we would have, with a probability of 1/3, we make 20. And with a probability of 2/3, we make -10. Okay, so this is probably looks like a 0. So let's quickly double check in Excel. So, okay, this is equal to 1/3 times 20 plus 2/3 times -10. It is 0. So the expected value from investment is 0. So that means if the investment expert tells us, oh, this looks like a failure, we will not invest but go with what we have, which is the 10. So then the decision is to not invest. Okay, we have here the 10. Okay, so now the final question is, what is the expected value of consulting? Okay, and we have seen earlier that the expected value of perfect information was 16, but now we are dealing with imperfect information. So what is that one? So we call it the expected value of consulting. So that means with a probability of 0.64, we make a profit of 12.5. And with the probability of 0.36, we make the 10. So how much is this? So 0.64 times 12.5 plus 0.36 times 10, 11.6. Okay, so it's only 11.6, and the expected value of perfect information was 16, and we said our willingness to pay for perfect information is 16, but we would only pay 1.6 for the expertise of that investment expert. So I covered a little bit more than what was being asked here. But you can see that in a problem like this, there are like many things that need to be considered. And so, but anyhow, yeah, let's just stop here. That concludes the lecture videos on probability. And yeah, I hope you found it useful. So thanks for watching.